So, hello, boys and girls. Today we are going to be doing um, subtracting fractions. And to start out, I'm going to ask you guys just to remember how we can subtract fractions that have the same denominator. If it has the same denominator, it's pretty easy. All you have to do is just subtract the numerators and then keep the same denominator in the answer. So if the question was 3/4 minus 2/4, the answer you would just subtract 3 minus 2 from the numerators, and the answer would be 1/4. But today we're going to be working on how to subtract when the denominators are different. This makes it a little bit trickier. But it's not something that we can't do. So we're going to start out with this problem. Sam and his friends ordered a pizza. After his friends finished eating, there was 1/3 of the pizza left. Sam then ate 1/4 of the pizza. How much is left after Sam and his friends ate? So there was 1/3 before Sam ate it, and there was 1/4 less after Sam ate it. So what are we doing now? Well, we know that based on the phrasing of the question, how much is left, we can pretty much figure out that it is a subtraction problem. So we are subtracting 1/3 of the whole minus 1/4 of the whole pizza. And that's important to remember, that it's all based on the whole in both of these fractions is the whole pizza. So we have 1/3 of the whole pizza to begin with, then take away 1/4 of the whole pizza, and how much do we have left? So if you notice, the denominators of these are different, like we had just said. And we can't just subtract the numerators for this, 1 minus 1, because they're worth different amounts since their denominators are different. To solve this problem, we need to find a common denominator. So this is a little diagram, a strip diagram of how we can represent these fractions. So this is the whole, and this is divided into thirds. So I'm going to draw on this to represent the 1/3. I'm going to color in the 1/3, and then I'm going to color in the 1/4 on this one, which is divided into 4 equal sections. Now, as you can see, obviously, these two strip diagrams right here for the 1/3 and 1/4 aren't divided up in the same way, which is why, again, we need to find a common denominator. A quick way to find a common denominator is by multiplying the two denominators together. So we know that 3 times 4 is 12, so 12 is the easy common denominator. As you can see, this bar diagram is already split into 12, which means, and if you can see, the lines of both the 3 and 4 line up to lines in the 12. That's how you can tell that it is a common denominator if the same lines from the 1/4 and the 1/3 line up to lines that are in the 12. So now that we have a common denominator, what we have to do is find equivalent fractions for 1/3 and 1/4, each with 12 as their denominators. So we're going to show you how to do that on this bar. So we're going to start out with the 1/3. Let's look at the strip diagram, and let's make it into 12 even sections. Since it's split into 3 already, we can just split each of the 3 sections into 4 even sections, which is really just multiplying the number of sections by 4. So let's try it. Um, I'm trying to move these. So yes, so we're going to divide each of the 3 sections into 4 even sections. So 2, 3, 4. So now there's 1, 2, 3, 4 sections there. Let's start with another one. 1, 2, 3, and 4. And then 1, 2, 3, and 4. Now, as you can see, this strip diagram is in 12 sections. And as you can see, the first 4 are shaded in. So that gives you a little hint as to what 1/3 is when you have the common denominator of 12. So let's try it for this. Because we already have 4 sections, and 4 times 3 is 12, we have to split each of the 4 sections into 3 even sections. This is an easy way to make them even. And again, because we know that 4 times 3 equals 12, that's how we know to divide each of the 4 sections into 3. So 2, 3 over here. 1, 2, 3 over here. 1, 2, 3 over here. 1, 2, 3 over here. So now we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 sections here. And as you can see, there is 3 of these sections shaded in. So this is a visual way of seeing how when we change the denominator, it's not changing the fraction necessarily as long as we change the numerator too. So we kind of naturally change the numerator when we change the denominator. So we split these sections up a little bit further. So the whole shaded section over here split into 4 sections, and the whole shaded over here split into 3. So we were essentially, what we were doing there is we were multiplying the amount of sections by 4 in the first one and 3 in the second one. So another way you can think about this that might help, and you can do it a little bit quicker, is whatever you multiply the denominator by, you also must multiply the numerator by in order to get the equivalent fraction. So over here we have 1/3, and we knew that 3 times 4 equals 12. So we knew that in order to get to 12 from 3, we just have to multiply by 4. So, because we multiply by 4 over here, we're going to do the exact same thing to this one in the denominator, in the numerator. So we're going to multiply by 4, which is going to equal 1 times 4 equals 4. And let's check over here. So we know that 4 times 3 equals 12. So what we have to do to 4 in order to get to 12 is multiply it by 3. That means we're going to do the same thing to this 1 up here. We're going to multiply this 1 by 3. So 1 times 3, of course, equals 3. So our new fractions are 4 over 12 and 3/12. Or I should say 4/12 and 3/12. So the new problem is 4/12 minus 3/12. And going back to this other slide, this is the same thing as we did here. We're multiplying the amount of sections over here by 4 and over here by 3, which in turn multiplies both the numerator and the denominator by the same number. And that's what we did here. So it's a little bit faster if you do it this way, but you could choose to do it either way. So now the new fractions are, like I said, the new problem is 4/12 minus 3/12. So now that we have common denominators, now that they both have the same denominator of 12, it makes it a little bit easier. And from here, we just have to subtract the numerators as if they were natural numbers. So we have 4 minus 3. Well, recalling subtraction, that's something pretty simple I can recall of 1. 4 minus 3 equals 1. And we're just going to put that with the same denominator of 12. So the answer is 1/12. So in putting it back to the pizza problem, we know the answer is there was 1/12 of the pizza left over after Sam and his friends all ate.